All right, question 12 on the GRE practice test 1 in section 5. Maybe the worst question I've ever seen on a standardized test. If you really saw this on your test, I don't know. I don't know what you'd do. This question is horribly worded. It's confusing. It doesn't really test anything mathematical. It's a bad question, but it's here, so let's do it. So we got a graduating class of 236 students, and what we're told is 142 of them took algebra, and 121 of them took chemistry. We're then asked what is the greatest possible number of students that could have taken both algebra and chemistry. Well, 121 is less than 142, right? You have fewer students taking chemistry than you have taking algebra. So if only 121 of them took chemistry, you certainly can't have more than 121 that took both. But there's no reason why all 121 of these students couldn't have taken both algebra and chemistry. Technically, the answer to the question is 121 students. You're like, no, that can't possibly be right. You didn't use this 236 number at all. Why would they give you that information if you were never supposed to use it? It's a good question. I could rewrite this question, call it 12A, and say in a graduating class of 236 billion students, 142 took algebra and 121 took chemistry. What is the greatest possible number, blah, blah, blah. And the answer is still 121. This number is not at all relevant to the question unless you change the question. A much better question 12 would be something like in a graduating class of 236 students, where each student had to take at least one of algebra or chemistry. 142 students took algebra and 121 took chemistry. What's the greatest possible number of students that could have taken both algebra and chemistry? With this added addendum, the question makes a lot more sense. It's a lot more interesting. You don't just pick the smaller of these two numbers and that's automatically your answer. This number becomes relevant all of a sudden. It's a much, much better question. So I'm going to go ahead and solve this alternate question 12 because my hope is this is what they meant to ask and this is what the answer would be, as opposed to this, which is just stupid. So in this scenario, a Venn diagram might help you. I got this blue circle representing students who took the algebra class. And I got this green, I guess almost circle, representing the number of students who took chemistry. I know that in total in the blue circle, so including this part and this part, I have 142. And in total in the green circle, so the part in the intersection and the part that's not in the intersection, I have 121. The challenge, the thing I don't know, is how many students took both algebra and chemistry. So maybe I throw a little X right here for the thing that I'm trying to find. If X represents the intersection of algebra and chemistry, and 142 students are in this blue circle, well then I know that 142 minus the X are in this portion of the blue circle. Similarly, 121 minus X are in this portion of the green circle. Since I have 236 students in total, and all of them lie in one of these three regions, this plus this plus this has to equal 236. So 142 minus X plus 121 minus X must be equal to 236. If I combine like terms, 142 plus 121 is what, 263, I guess? And then I got minus 1x, minus 2x's, but then plus 1x. So I have net of minus 1x is equal to 236. If I add x to both sides of the equation and subtract 236 from both sides of the equation, I get that x is equal to 263 minus 236, which I guess you could throw into a calculator or something if you don't feel like doing math in your head. I think that ends up being equal to 27. I guess in this alternate question, where we're told that all the students had to take at least one of these two classes, we wouldn't ask what is the greatest possible. We just ask what is the number of students that, took both algebra and chemistry. I think this is what the question should be. I think as written, it's a pretty weird question, but as written, the answer is 121, and this 236 number is completely irrelevant. In this alternate question, the answer would be equal to 27. Before ending this video, in the interest of teaching about the entire test and not just this specific problem, I want to give you a couple hints about problems that are kind of like this. The first one, I guess you could sort of think of as a formula. It says anytime you're trying to find the union of two different sets. So in this specific problem, the total number of people in this blue portion plus this middle portion plus this green portion. The number of people that took at least one of these two classes. All you have to do is figure out how many people took one class, A, for algebra, and then add the number of people who took the other class, B, for chemistry for some reason, and then subtract out the number of people that took both algebra and chemistry. This is a little formula that might be worth remembering. I wouldn't say memorizing because it's pretty easy to understand what's going on here. When you're adding A and B, here's me shading in A, and here's me shading in B, you don't get the union of the two sets because you kind of counted this intersection twice, right? I shaded it in blue, and then I also shaded it in green. So because it gets double counted when you just add in A and B, you have to subtract that intersection one time so that you only count everybody one time. That's all this formula is saying. With this formula, we could have done this problem a little bit cleaner. We could have said we know there's 236 total students in here, and that has to be equal to the amount who took algebra, which was given to us to be 142, plus the amount who took chemistry, which was given to be 128, minus the number of students who took both algebra and chemistry, the thing we're trying to figure out. Actually, if you stare at what I have written right here, it's exactly what we have written right here, except the 236 is over on this side, and instead of writing 142 plus 121, I wrote that sum 263. You might have been able to shave off a couple of seconds on this problem if you started out with this formula and then jumped directly to here. And you're like, nah, not really worth it. Well, what's cool about this formula is it extrapolates to having more than two sets. If I had 3 different classes, I don't know, algebra, biology, and chemistry maybe, and I was interested in the number of students who took any of those classes, at least one of these 3 classes. I'll switch colors because that's getting kind of dark here. I could kind of start out like I did over here where I just add up the sets themselves. So I could start out saying that's A plus B plus C. But as you can see, if you start shading these things in, if you shade A, then B, then C, you're going to be over counting these groups in the middle. Fortunately, there's an easy solution for that. All you have to do is subtract out each of the different intersections. So A intersect B, subtract out A intersect C, subtract out B intersect C. It's kind of a fun exercise to go through and like shade these in and then subtract out one version of them and make sure that you have everything covered. If you do that, you'll see that you don't have everything covered. What I have written right here counts everybody in this section once, everybody in this section once, everybody in this section once, everybody in this little section once, this section once, and this section once. But unfortunately, this middle section isn't counted correctly because I started out counting them 3 times, once for A, once for B, once for C, but then I subtracted them out 3 times, once for A intersect B, once for A intersect C, and once for B intersect C. So I triple counted them and then subtracted them 3 times. I haven't counted them at all. In order to get the union of A, B, and C, I need to add that intersection in one more time. This over here is kind of the 3-set version of this formula over here. And if you care to, you can come up with the 4-set version of this formula over here. It's kind of the same idea. Add each of the 4 sets, subtract out all of the pairwise intersections, but then add back in all the intersections of 3 sets, but then subtract out the intersection of all 4 sets. The formula works for as many sets as you want it to. Although for the purposes of this test, I can't imagine you'd need more than this 3-set version, and the most likely one you'd use would be this 2-set version right here. One more piece of information loosely related to all this stuff are what are called De Morgan's laws. And those deal with complements of sets. So like the number of students who did not take algebra, for example. And what they tell you is that, let's see if I can say this right. The complement of the union is the intersection of the complements, and the complement of the intersection is the union of the complements. I think I'm saying that right. If I wanted A union B complement, so the number of students who did not take algebra or biology, one way I could come up with that is I could figure out how many students did not take algebra and then intersect that with the number of students who did not take biology. The complement of the union is the intersection of the complements. Similarly, if I wanted to know how many students there were who weren't enrolled in both of these classes, well, A intersect B represents the number of students who are enrolled in both classes, so the complement would be those who are not enrolled in both classes. One way I can represent the complement of the intersection is just by finding the union of the complements. Figure out the union of the students who did not take algebra and the students who did not take biology. I probably should have left this last part out because it's not that closely related to this specific problem, so it might seem a little bit abstract. But trust me, De Morgan's laws are really useful when you're doing some kind of elementary set theory stuff. And I could absolutely see a question on your test that would be made a lot easier if you knew these laws. And since they're so nice, they're easy to memorize because of the symmetry in here, it might be worth writing them down. Google it, go check out a Wikipedia page on it or something. I mean, don't spend forever, but at least now I've told you about it.